Hi ladies, it's Mr. O'Sullivan. Today is February 2nd. What we're going to be doing today is we're going to be starting a new unit, and it's going to be called Basic Triangle Proofs. So before we even begin with the triangle proofs, we're going to be going over the algebra behind it. So this unit is not going to be a lot of computation. Again, it's going to be similar to our last unit. It's going to be a lot about drawing conclusions. There's going to be a lot of fill-in-the-blank proofs, and a lot of the stuff we'll be doing will be on Desmos. So let's begin. Today's learning target is I can apply properties of congruence to determine what sides and angles are congruent by analyzing figures. So when two figures are congruent, there are two very, very important properties that we need to take into account. Their corresponding angles are congruent and their corresponding sides are congruent. And we know what's going to be corresponding by A, looking at our image, and B, by looking at our congruence statement. So a congruent statement relates one identical object to another by identifying the corresponding parts that match up to each other. It's actually very straightforward. The first matches with the first, the second with the second, and so forth. But before we begin, if you look, this is the congruent symbol. We've been using this regularly. So the equal part stands for our equality. So our equality. And that basically says same size. And the part above our equal sign, or sort of looks like the tilde over the letter N in Spanish, stands for our similarity. So basically saying that our figures are going to be similar, which means that we're going to have the same shape. So in this example, I have parallelogram ABCD is congruent to parallelogram WXYZ. So what's nice about this is A corresponds to W because that's the first letter. B corresponds to X because that's the second letter. You can probably take a guess as to what C corresponds to. C corresponds to Y. And then last but not least, D corresponds to Z. So when we look at this, we can actually say that angle A is congruent to angle W. I'm going to use one semicircle. I can say angle B is congruent to angle X. I'm going to use two semicircles now. C is congruent to Y, so 1, 2, 3, and then D is congruent to Z. So I'm not saying that the sides are congruent, I'm saying that their angles are congruent. I can also say that my sides are congruent as well, but we're going to look at that in our next example. So quadrilateral BADC is congruent to quadrilateral EFGH. The first thing we want to do is we want to write all congruent statements about our corresponding parts and mark our angles and sides that are congruent in our image. So what I'm going to do is, I have quadrilateral BADC is congruent to quadrilateral EFGH. Let's look at our angles first. My first letter is a B, my first letter is an E. So I can say angle B congruent to angle E. I can then say angle A congruent to F. Angle A is congruent to angle F. I can then say angle D is congruent to angle G. And then last but not least, I can say angle C is congruent to angle H. Now I'm going to mark my image. So one semicircle on B, one semicircle on E. Two semicircles on A, two on F. 1, 2, 1, 2. D and G are congruent. 1, 2, 3, 1, 2, 3. And then last but not least, C and H. 1, 2, 3, 4, 1, 2, 3, 4. Perfect. So that's how I mark my angles. Now I want to mark my sides that are congruent. So what I'm going to do is I'm going to rewrite BADC congruent to EFGH. So if I look, I have BADC congruent to EFGH, and all we're going to do is actually just pick and choose two letters. I'm going to look at BA. Those are my first two letters. So I can say my first two letters over here are also congruent, EF. So I can say segment BA congruent to segment EF. So when I mark my image, BA congruent to EF, one tick mark. Now I have DC. So I can say DC. Let me erase my BA being boxed and my EF. I can now say DC and GH are congruent. So line segment DC, congruent to line segment GH. So I go to my image and I mark DC and EH are congruent. So 2 tick marks this time. Now, I'm going to do erasing again to make sure it's nice and neat. So now I can say that my whole segment of BC is congruent to EH. So I can say BC congruent to EH. And boom, those are corresponding. So now I'm going to do 3 tick marks. 1, 2, 3, 1, 2, 3. And then by process of elimination, I haven't done my FG and AD, so I can say FG and AD are congruent. And then I would do 4 tick marks. 1, 2, 3, 4, 1, 2, 3, 4. So the reason why FG and AD are congruent is because of this. Let me erase. Well, if you look, they're my 2 middle letters. So FG and AD. And that's it. And we just marked our image. So basically every single thing in your congruence statement is true. It's going to be up to us to figure it out. Okay, now let's go on to our next example. So now what we're going to do is we're just going to practice again naming our congruent angles and naming our congruent sides. So in this image, I'm given triangle ABD congruent to triangle BAC. So if you want, you can sort of emphasize which triangle is which. I can do that as well. So you can say triangle ABD is my red triangle. And then I can say triangle BAC is my blue triangle. So start at B, go to A, end at C. We'll come back to B. So if you look, we can say that angle ABD is congruent to angle BAC. I can say angle ABD, so basically go right in order, is congruent to angle BAC. And we're going to mark that. So ABD, sorry, so ABD, so this angle is congruent to angle BAC, this angle. Now, I can say angle ADB congruent to angle BCA. So I'm going to mark that now. So angle ADB congruent to angle BCA. 2 semicircles. 2 semicircles. And then last but not least, which angle am I missing? And then I have my whole angle. So I can say angle DAB congruent to my whole angle over here of CBA. I wouldn't really worry about this image that much. And now my sides that are congruent, well, I can just look at my image, or I can, well, not look at my image, I can look at my congruence statement. If I look at my congruence statement, my first letter and last letter are AD and BC. So I can say AD congruent to BC. So I'm going to put 1 tick mark on AD, 1 on BC. I can now say that AB and BA are congruent. Which we actually already know because look, that's the reflexive property. So you can just say AB congruent to BA or AB congruent to AB. And then last but not least, I have BD congruent to AC. So I'm going to mark that. BD congruent to AC. And there's going to be some practice with this on the Desmos. Okay, now let's go on to the next part. So again, we're just going to practice naming the stuff. So if I look, I have triangle ABC is congruent to triangle DEF. If we look, we can say that angle B lines up with angle E. So I can say that angle B and angle E are congruent. And if I look at my image, I know what the value of angle E is. Angle E is 93 degrees. So I can say angle B is also 93 degrees. And I'm going to do, I'm actually going to put that in my image. Now angle F. Angle F. If I look, angle F lines up with angle C. So I can say angle F and angle C are congruent. And if I look at my image, angle C is 73 degrees. So I can put a nice 73 degrees right here. Now AC. AC is going to be congruent to DF. So if you look, DF is 7.6. So AC will also be 7.6. Now DE, that's my first and my second. So that's going to be lining up with AB. So if I look at AB, that's 5.4. So DE is going to be 5.4 as well. And that's it for that section. Okay, now on to our next set of problems. If triangle ABC is congruent to triangle CDA, mark your congruent sides and angles. Well, I know angle A and angle C are congruent. So I can say that this angle and this angle are congruent. I can say angle B and angle D are congruent. And then I can say that this angle is congruent to this angle. I know AB is congruent to CD. And I know AD is congruent to BC. And then I have my reflexive of AC. So if the measure of angle D is 80, what is the measure of angle B? So if you look, I'm going to put an 80 in here. And if I look over here, I want to find out angle B. Well, they both have one semicircle, so they're going to be congruent. So I can say angle B is equal to 80 degrees. And that's your final answer. Number 2, if AD is 17, so I put my 17 here, and BC is 5x plus 2, find the value of x. Well, if you look, both sides are congruent to each other. So what I'm going to do is I'm just going to do 5x plus 2 equal to 17. So I want to solve for x, so the only way to do that is I have to get my 5x by itself. So I'm going to take away 2 from both sides. So I get 5x equals 15. And I want to get rid of that multiplied by 5, so I'm going to divide both sides by 5. Divide by 5, divide by 5, and I get x equal to 3. Let's go on to the next example. If the measure of angle D is x squared and the measure of angle B is 12x minus 36, what is the value of angle B? What is the measure of angle B, sorry? So if you look at this example, what we're actually doing is we know that angle D and angle B are congruent. So I can do x squared equals 12x minus 36. Whenever we have an x squared, we want to get everything on the side of the square. So I'm going to take away 12x, add 36, take away 12x, add 36, cancel, cancel. So I get x squared minus 12x plus 36 equal to 0. I want to find two numbers that add up to negative 12 and multiply to 36. Well, I know that's x minus 6 and x minus 6 equal to 0. And now t time, and I get x minus 6 equals 0, x minus 6 equals 0. That's the exact same set of factors. The only way to solve, add 6 to both sides. So I get x equals 6, and I do the exact same procedure here. Add 6, so I get x equals 6. Here's the thing, x equals 6. But it wants you to find the value of angle B, so we have to plug back into angle B. We know angle B is 12x minus 36. So everywhere I see an x, I'm going to substitute a 6. 12 times 6 is 72. 72 minus 36, 36. So angle B is 36 degrees. And that's it for today. Make sure you complete your your Desmos activities. And if you have any questions, please email myself or Miss Danielle. Have a great day, ladies.